So we are going to finish up the section 6.4, and we will be looking at another use for the dot product. All right, so here's what we got is orthogonal vectors. An orthogonal vector, what that means is vectors that are perpendicular to each other. Vectors u and v are orthogonal if the dot product of u and v is equal to 0. You'll see that when two vectors are perpendicular to each other, they would form right angles, so the dot product of each of these vectors would be 0. Determine whether the vectors are orthogonal. Well, we need to do the dot product. So I'm going to take the vector u, which is 2, -3, and put it with the vector -3. Actually, this should be a 6. I think this is a misprint here. Just 6. 6 and 4. Then what we've got is 2 times 6 plus -3 times 4. That's 12 plus -12, which equals 0. So we can say, yes, u is perpendicular to v. U is perpendicular to v. All right, something else we want to talk about real quick, and it's not in your packet, but we want to talk about parallel vectors. If two vectors are parallel, then one of the following occurs. 1, v is equal to c times u, or u is equal to c times v. C is just a constant or a scalar, a number. So for example, if v is equal to 4, -6 and u is equal to 2, -3, the best thing for us to do is do a ratio. Do the ratio of x's. 4 to 2, does it equal -6 to -3? And the answer is yes. So these are parallel. V is parallel to u. You can see all you have to do is multiply u times 2 and you'll get to v, and so it is a multiple of that. All right, we're going to look at now what the projection vector is. A projection vector is this. Okay, if I'm doing a projection of u onto v, this is the symbol for that. That's a little subscript v. This is what the projection vector is. It's the vector here on vector v that goes slightly below, and then this vector that goes from v to the end of vector u would be perpendicular. So the actual projection vector, again, is the vector on the bottom here. And what we call that is we call that w sub 1, and then the altitude is w sub 2. The projection vector is the vector that has the distance from the vertex to the point at where the altitude connects with the vector. That's for the acute angle. Let's look at now an obtuse angle. An obtuse angle, we need to extend our vector backwards so that we can get the perpendicular here. There's my altitude. So this is W1 and this is W2. So what we're actually finding when we find the projection vector is we're finding another vector. Here's the formula to find it. The projection of u onto v would be the vector u dot product, vector v, divided by the magnitude of vector v squared, and then multiplied by vector v. This expression right here is going to give us a scalar. And when you take scalar multiplied by a vector, the output will be a vector. And that vector will be in the direction of vector v. One other thing to note is if I do have this projection vector of W1 here in the bottom, and we have the altitude of W2 here, and that's perpendicular. Well, U, this vector U actually is the sum of W1 plus W2. It's vector addition. W1 plus W2 will actually equal the length of vector U. All right, here we go. So we're going to do the projection. Find the projection of U 3, -5 onto V 6, 2. Then write U as the sum of two orthogonal vectors. So our goal is to do U equals W1 plus W2. And we're going to have to find those vectors. So in order for us to find W1, we do the formula, the dot product of 3, -5 and 6, 2 divided by the magnitude of each of them. The magnitude of the first one is 9 plus 25. If you take the square root of each of these, excuse me, but we got to find the magnitude of 6, 2. So it's the square root of 36 plus 4, which is 40. And then we're going to square that. And then you multiply it by vector v, which is 6, 2. So all of this right here is going to give us a scalar. Let's do the dot product. The dot product would be 18 plus -10, which is 8, over the root of 40 squared, which is 40, times 6, 2. So we have 1/5 of 6, 2, which equals 6/5, or 1.2, and 2/5, which is 0.4. All right, there's W1. Now we're asked to write the answer. This is the projection of V onto U right here. We're asked to write the answer as the sum of W1, so W1 is 1.2, comma 0.4, plus W2. So we need to find W2. Here's a reminder of how we will find W2. W2 is equal to vector U minus vector W1, which is the projection vector. We're going to do U minus W1. So U is this, and W1 is 1.2.4. So 3 minus 1.2 is 1.8, and -5 minus 0.4 is -5.4, and that is our answer. This is how you find the projection vector. Now the only thing that I didn't do is I didn't show you where that projection vector would be at. It is the vector, if you draw in the perpendicular from U to V, you draw in the perpendicular, it'd be right there. So the actual vector, projection vector that we found, is this little segment from the vertex right there. All right, here's your assignment.